Today I'm going to explain about the scheduling algorithms. Okay, so before that, we discussed in the previous video what do you mean by CPU scheduling and the major scheduling criteria. That means whenever our scheduling algorithm selecting any process in the main memory from the ready queue, so it has to think about the 5 criteria. That means it has to select the process such a way that waiting time, average waiting time should be very less, average turnaround time should be very less, and average response time should be more, throughput should be more, and CPU utilization should be more. So waiting time means how much maximum time, how much time a process waits in the ready queue to get the CPU time. That is the waiting time. Okay, turnaround time is calculated by adding the waiting time of the process, the total waiting time, and plus the total execution time. Okay, total, that means the time when it arrives to the ready queue till its completion, total time, that is the wait time plus execution time. Okay, this execution time is also called as burst time, CPU burst time also. Okay, so the response time, that means response time means when our process starts responding, at what time. So that's what the response time, this is the start time. At what time it starts minus arrival time. Okay. So this is the formula. And throughput, how to calculate the throughput? Here execution time, you add execution time of all the process and divide by the number of processes. That is what the throughput. Okay. So these are the things. And we also discussed these are the scheduling algorithm. First come, first serve, shortest job first, shortest remaining time first, priority scheduling algorithm, and round robin algorithm. Now in this video, I am going to explain about first come first serve scheduling algorithms. So let us discuss now first come first serve. This is the basic scheduling algorithm and the simplest scheduling algorithm. So this is the first come first serve. Okay, as the name itself suggests, first come first serve means whichever the process which arrives first, that has to execute it first. So that's what the name first come first serve. Okay, to implement this scheduling algorithm, so there is no option, we have to use the queue data structure because queue is in first out, okay, property. So as the name itself indicates, whichever the process arrives first, in what order they arrived, okay, and in that order only we need to execute. So hence first come first serve. And this is a non-preemptive scheduling algorithm. Non-preemptive means once we started, till its completion, we are not stopping. After completing one process, then only we are taking the next process. So it is a non-preemptive scheduling algorithm. Let us take one simple example. Consider 4 processes, P1, P2, P3, P4. Okay, these 4 processes arrived at 0 milliseconds. Okay, assuming all these processes arrived, okay, arrival time is equal to 0. That means at the 0th time only. That means at the same time all these processes arrived and this order only. Assume P1 comes first, P2 comes, P3, P4 at the same order. Every process arrived at 0th time only. But the meaning of this one is process 1 required 20 milliseconds to complete its execution. Burst time is also called as execution time. That means process 1 needs 20 milliseconds of CPU time to complete its task. Okay, that's what the CPU burst time or execution time. Similarly, P2 requires 4 milliseconds of CPU time to complete its operation. Similarly, P3 requires CPU for 5 milliseconds. P4 requires CPU for 3 milliseconds to complete this task. So this is what in the exam they will give like this one data, and now you need to find out what is the waiting time. Okay, what is the waiting time? So then what is the turnaround time? Okay, we discussed in the previous video, turnaround time. Okay, and sometime they will ask also for response time. Okay, response time. Okay, these are the things what they will ask. Okay, so now let us see. Now in order to find all this waiting time or turnaround time or response time, first we need to write one Gantt chart. Okay, so Gantt chart. So Gantt chart is symbol, horizontal bar. It indicates which process starts at which time, ends at what time. Okay. So now I write. So simply start like this. Okay. Now since the 0th second, at the 0th millisecond, all the process P1, P2, P3, P4 arrive in this order. I start with 0. At the 0 time, which comes first? We know that according to the table, P1 comes. So I have to execute P1. P1 I have to execute. Now, once I start P1, we have to complete this P1, then only we have to take the second one. Okay, next one. Because it's a non-preemptive scheduling algorithm. So P1 requires 20 milliseconds, that means up to 20th milliseconds. Okay. From 0, you add this execution time, 0 plus 20, 20. That means for up to 20 milliseconds, P1 would be only took the time. So next, so now P1 completes. Once after P1 completes, then we need to start what? P2. Okay, P2 I have to start because this comes second. Okay, now P2 requires 4 milliseconds. Okay, now P1 over at 20th millisecond, 20, and then now P2 starts at 20 and P2 requires 4. So 20 plus 4, 24. That means P2 runs till 24 milliseconds. Now P2 also completes. Next I have to start P3. So now P3 requires 5. So P up to 24, 20 to 24, P2 executes. From 24 onwards, P3 executes. From 24 onwards, P3 requires 5 means 23, 25, 26, 27, 28, 29. So to 29. So P3 runs up to 29 milliseconds. Now P3 also completes. Next P4. So now P4 have to execute and P4 requires 3 milliseconds. Up to 29, 24 to 29, P3 executes. Now from 29 onwards, P4 starts. 29 to 30, 31, 32. So 3 milliseconds, 32. So 32 milliseconds up to 32. Now this is the Gantt chart. Simple, right? Okay. So this is simple Gantt chart. If you write this simple Gantt chart for the given table, you get minimum 2 marks. Okay. So now you can cross verify how it is correct. See, you add this completely. 20 plus 4, 24, 24 plus 5, 29, 28 plus 3, 32. If you add, what is the number you got? That should be the last. Suppose the last ending time of the last process in the Gantt chart is not equal to sum of the execution time of the process, means you did somewhere wrong. So sum of, if you add all these execution time of all the processes should be equal to the last ending time of the Gantt chart, which both are same. So then your answer is right. Now I written the Gantt chart. Now from the Gantt chart, now I need to find out what is the waiting time of P1, what is the waiting time of P2, what is the waiting time of P3, what is the waiting time of P4 to calculate. Now if you look into this P1, P1 starts at what time? See, now this is the start time. Okay, starts at what time? 0th. It comes at what? 0. So P1 waits for 0. That means it came at 0, it starts at 0. Doesn't wait anything. Okay, so it's 0 milliseconds. Now, P2 starts at what? 20 milliseconds. P2 starts at 20 milliseconds, but came at 0. 20 minus 0, 20. So that means P2 wait for 20 milliseconds. So next P3, so P3 when it starts, P3 starts at 24. Till that it waits, because it waits for P1 to complete, then P2 to complete, then P3 starts. So P3 waiting time is what? 24 milliseconds. Similarly, P4, how much time? 29 milliseconds it waits. Now, so this is the average, so it is the waiting time of P1, this is the waiting time of P2, this is the waiting time of P3, this is the waiting time of P4. Now I need to find average waiting time. Average waiting time is what? You add the sum of waiting time of individual process divided by the number of processes. So here we see 60, 73. Okay, 20, 20, 60, 69, 73. So 73 divided by 4. 73 divided by 4. How much will get? If I do 73 divided by 4, we'll get 18.25. That means 18.25 milliseconds the average waiting time. That means if you apply first come first serve scheduling algorithm, for this numerical, the process will wait, every process will average 18.25 milliseconds it has to wait. Okay, now let us find out the turnaround time. See again, turnaround time formula. turnaround time formula is what? So total waiting time of the process plus execution time or burst time. Okay, so now I will write here only, no problem. So it is waiting time plus execution time or what? Burst time. Now, waiting time we know 0, P1 waiting time 0 plus its execution time 20. So I will write this as 20. Okay, this as 20 milliseconds. You have this. Now, waiting time of P1 is 20, execution is 20, so 24, similarly 24 plus 5, 29, this is 32. Now, again I need to find average turnaround time. Okay, so again, turnaround time is waiting time plus execution time, waiting time plus, you add this, waiting time, execution time, waiting time, execution, waiting time, execution, waiting time, execution time. I got this. Now to find the average turnaround time, again add all these 4 and divide by 4. Okay, if you do that one, 60, 90, 92, 101, 105. 105 divided by 4 is equal to how much you get? 105 divided by 4 is equal to 26.25 milliseconds. Okay, this is the average turnaround time. Okay, so now response time. Response time means once we see always our process starts responding when it starts executing. Okay, so formula for response time is start time minus arrival time. Start time minus arrival time. But here arrival time is 0, so minus 0 always, so still be the start time. When the P1 starts at 0. When P2 starts at 20. When P3 starts 24. So when P3 first 20. See exactly, if you observe waiting time and response time, it is exactly same. For most of the problem, waiting time and response time will be similar. Okay, and we return all this waiting time, turnaround time, response time from the Gantt chart only. So Gantt chart is very, very important. If you make here only the mistake, then complete remaining portion of the problem will be completely wrong. So be careful. First write the Gantt chart properly and then accordingly write the waiting time, turnaround time, all this. Okay. So now average response time, again as usual, we add all these things, divide by things, same thing, 18.25 milliseconds I got. Now in the exam sometimes they will ask throughput, that is the one more scheduling criteria. What do you mean by throughput? Sum of execution time of all the process divided by the number of processes. So sum of execution time. So you add all these things, sum of execution time, all these things, 20, 24 plus 5, 29, 29 plus 3, 32. 32 divided by what? 4. Correct? 9, 12, 32. So you got how much? 8 milliseconds. So this is the throughput. That means every 8 millisecond one process will complete. That means, so in general, this is the process. Each process takes this time. On an average, so it will take 8 milliseconds to complete one process on an average. So that is nothing but the throughput. So we know how first come first serve works. Well, okay, and then what type of scheduling algorithm? It is a non-preemptive algorithm. For the given numerical or the given problem, how to find out waiting time, turnaround time, response time, and throughput, average waiting time, average turnaround time. Okay, so hope you people understood this. Now, if you observe, this is very, very simple. Whichever that come first, that we are executing. But there is some problem, is there? What is the problem? The problem is, see, if you observe P4 needs only 3 milliseconds to execute, right? P4 requires only 3 milliseconds, but it waited 29 milliseconds. To execute 3 milliseconds, it is waiting 29 milliseconds. So that is the problem. Almost 10 times it will, almost 10 into 3, 30. Almost 10 times it is waited. Okay, that means you not execute 3 milliseconds, waited 29 milliseconds. That is the problem. Similarly, if you observe, for 4 milliseconds to execute, it has to wait for 20 milliseconds. So that is the problem with what? First come first serve. So for this, what we will do, instead of making the process, that means instead of making the process which takes less time to execute to wait for longer time, you execute the shortest job first and then make largest. That means this is longest. Instead of executing this first, you execute another one. Suppose now, if I execute in this order now, suppose if I execute in this order, P1, P2, P3, okay, not in that. So here, instead of that, I will push. Okay, so suppose I got in this order. Suppose, for example, if I got the process in this order at the same time, arrival time still it is 0. If it comes in this order, same thing. P2 requires 4 milliseconds, P3 requires 5 milliseconds, P4 requires 3 milliseconds, this requires 20 milliseconds. Now let us see what is the average waiting time, all those things. Let us see now. Okay. Now we'll write the Gantt chart for this separately. So 0 seconds. Now here which comes first? P2 comes first. Okay, P2 comes first and it starts executing. So P2 requires how much? 4 milliseconds. So it's ended 4th milliseconds. Next after P2, P3 comes. So P3 it requires 5. So 4 plus 5, 9. So then P4 comes. P4 requires only 3 milliseconds. So 9 plus 3, 12. And finally now P1 comes, it requires 20. So it will be 32. See, same thing. Here also last is 32. Here also last is 32. Now this is the Gantt chart for this version of this problem. Now let us see. Now here, now it calculate waiting time. Waiting time. How much P2 waits? P2 starts at 0 means it doesn't wait at anything. P3 starts at what? P3 starts at 4 milliseconds. Okay. P3 starts at 4 milliseconds means it waited only for 4 milliseconds. P4 starts at 9 means it waited only for 9. P1 starts at 12 means only 12. So now you add this one, 12 plus 9, 21. 21 plus 4, 25. So 25 divided by 4 is equal to 6.25 milliseconds. See here, 6.25. 6.25 milliseconds. That means it waited only for average waiting time of these processes if they arrive in this order 6.25 milliseconds. But you see here 18.25, where 18.25 is almost 1 by third, 33% it is reduced now. 18.25 average waiting time to 6.25 milliseconds. That is the beauty of this concept now. Okay, now say again, so waiting time, turnaround time. If I calculate turnaround time, so now execution time plus waiting time, 4, 9, 12, 32. Now if you add this 44, 48, 57. 57 divided by 4. Okay, 57 divided by 4 is equal to 14.25 milliseconds. See here, average is 26.25. Here average is 14.25, almost 50% reduced. Okay, turnaround time. Similarly, again, if you take response time, it will be same because start time minus what is arrival time? Arrival time is 0. Start time is only what? Start time is waiting time only. You get 0, 4, 9, 12. Response time will be the now same thing 6.25 milliseconds. Okay. Now let us calculate throughput for this. Throughput is same. Get same thing here also. What is the throughput? 8 milliseconds here because you have to add all these things and divide by n. So throughput will be same. But if we make whichever the processes which request less time, you execute first them, and finally the process which executes needs more time last. So then average waiting time and average turnaround time will be reduced drastically. So we know what is first come first serve. So what type of scheduling algorithm is non-preemptive scheduling algorithm, and how to calculate waiting time, turnaround time, response time, and average waiting time, average turnaround time, how to calculate the throughput, and what is the disadvantage of this regular first come first serve, and not to overcome that, so how we can make. Okay, that also we discuss. Hope you people understood in detail first come first serve. Okay, if you have any questions or if you have stuck in any other problems related to the first come first serve, you can read it in the comments. Definitely I will solve for you people. So thank you. Thanks for watching.